My name is Perry Clausen. I'm Executive Director of the San Joaquin Water Quality Coalition. When you do your reports and you have high nitrates in your water, we want to encourage you to integrate that number into your fertilizer, your nitrogen application that you put on each year. One thing that we know about the pump and fertilize is that there's really only two ways to clean up our aquifers that have high nitrates. One is we put more water in it, you dilute the nitrates that's in the groundwater. Your dilution is a solution in this case, which hopefully Sigma is going to help us out on. That's one approach. The only other approach there is pump that water out with a nitrate, put it on a crop, and have the crop uptake that nitrate. Treatment is there's no way treatment would be feasible to pump that water out and treat it through reverse osmosis or some other method. That would cost a fortune. It wouldn't be practical. So the water board, the activists really love this approach because it is something that is usable to clean up, or it's practical to clean up our waterways. However, there's a big however on this, and if you've been to our member meetings, we've repeated it, but it's worth repeating in case you weren't listening at that moment. All right, so here's the example. You got 35 parts per million of nitrate in your groundwater, just an example. If you put on 30 acre inches of water, that equals 236 pounds of nitrogen per acre that's coming on in your irrigation water. And there's been enough studies now to show that that is usable by the plant. However, the big qualifier of that is that 30 acre inches, that assumes that all 30 acre inches of that water is used and taken up by the tree. And that's not possible. It depends on your irrigation efficiency. A good example also that it's not practical is right now it's so dry. We haven't had rain since December. There's a lot of us that are out there irrigating our trees just to get that soil profile filled up. That tree is not taking up nitrogen right now. But if you put on 6 inches, you shouldn't take the assumption that I just put on, and I'm doing the rough math, that I put on 25 pounds of nitrogen because your tree did not take up that nitrogen. So the number that we're using, and this is something to talk to an agronomist about that knows your orchard well, is maybe you half this. Maybe you do 115 pounds in your budget and say, I'm likely going to be able to get 115 pounds per acre of nitrogen from my irrigation water if it's 35 parts per million. And if your crop needs 180, then it's legitimate to supplement that with another 70 pounds of nitrogen or whatever the number is. So again, try to take advantage of it, but don't depend on it totally to be your nitrogen source because of the efficiency problem of that. And I had a grower up that had even higher. He had, I think, about 70 parts per million of nitrate in his groundwater. He said, all right, I'm going to try it. I'm going to not fertilize my crop. He had yellow leaves before harvest. And his tissue testing showed that he was deficient in nitrogen. And it was because, in thinking about it and looking at it, it was because of this factor, is that trees did not take up all of that nitrogen because water that's around the tree and not in the roots wasn't taken up and used by that tree to grow the crop. So anyway, it is something worth considering and using. There's the thought at the State Water Board that there's acceptable ranges of fertilizer applications for each crop. And they're asking the coalitions to submit to them, with the help of the university and with commodity groups, what's an acceptable range of nitrogen to put on for a certain amount of yield. So if you get 2,000 pounds of nut meats, what is the acceptable range? And we got a long ways to go to define some of these terms. Acceptable to who? My argument, acceptable for good production and a quality crop. But they want us to publish acceptable ranges for nitrogen application for almonds at a certain yield level. So we're still working on that. I don't know what the right number is. We've got the basis of it, what Sebastian talks about. But we have to do this for every crop grown in the coalition, well, in the Central Valley. Then, as I mentioned earlier, these crop nitrogen coefficients, we have some that are not so good, as I mentioned earlier, so that we need to improve these. I mean, this is our curve that we're being graded on. These crop coefficients are the number that we are being compared to to determine this excess nitrogen. So we have to have good coefficients for our crops by March 2021. I think as I mentioned, we're good shape with almonds, pistachios, and walnuts. And then for 95% of our acreage, and then 99% of the acreage by March 2023. Then the other thing that we're working on is what's called the Management Practice Evaluation Program. And this is a program where we're identifying practices that growers can use that are going to help with an efficient nitrogen applications. What you're going to hear today from Sebastian is the 4 R's, the right time, right place, right amount, right product, and we're really going to hang our hat on those. Those are developed by the commodity group specific for those crops. So we're evaluating those in field studies. University is looking at them to see if, in fact, when you use the 4 R's, are you protective of groundwater? That's the overriding theme. They want growers of irrigated croplands to not cause or contribute to groundwater contamination with nitrates. So when we find effective practices, that's what they will do. The last issue, I know some of you were in the annual meeting. I got my jars and stood up in the front and did this illustration. So this groundwater protection formulas, values, and targets. The initial draft of the new order said that they wanted each grower on each field to do analysis of how much nitrate's going past the root zone into the aquifer below their field. We said there's no way that that's practical. The cost would be enormous. So let us as coalitions develop this groundwater protection formula, value, and target for a township range, 36 square miles. So where it'll take all the data of A minus R, the applied minus remove, equals the excess. And here's an illustration that we use. So we take the A minus R of all the fields in that 36 square mile area, and then we subtract the amount of water that may be going in the groundwater from rainfall and nearby waterways and other things, microbial degradation, the gassing off of nitrogen. And we put that in a calculation or in a formula, and that gives us our value. So the value is then compared to the target that is that we have to reach in the groundwater. Right now for nitrates, it's 10 milligrams per liter that we have to meet in the groundwater. So what we're going to do over the next 35 years, we're given 35 years to reach the target, is come up with interim targets that we can hopefully meet in this groundwater aquifer. This is very complicated. We have not come up with a formula yet of how we're going to do that, but we have to turn one into the regional board here this summer, and it's going to be challenged, I'm sure, but this is going to be our overall agriculture grading system, if you will. It's going to take individual information and then determine over a large area whether we are causing or contributing to nitrate contamination in groundwater.
My name is Sebastian Sa. I would like to start my presentation with this slide. By way of background, this slide illustrates all the essential nutrients that are needed to grow the plant, any plant, and to grow almonds. And the interesting thing of this slide is that it's grouping the different nutrients that are needed to grow plants by the amount of management that you need to invest in the different nutrients. In red, those are the nutrients that in almond production you always have to manage. Every season, every year, you need to think about those nutrients. In yellow, the ones that you have to monitor and manage accordingly, and the ones in green, isolated occurrence. So why do I bring this up? Because as you will listen through my presentation, that I will mainly focus in nitrogen, I do think that the principles and concepts that I'm going to discuss today do hold for all these elements. So keep that in mind, that whenever we talk about the 4 R's or whenever we talk about the nitrogen budget approach, it's also important for potassium and other elements to keep in mind. Going into the specifics of nitrogen, whenever we think about nitrogen, we need to think about the 4 R's concept. Do you guys know about the 4 R's? Have you heard them before? I will say that yes, I see a couple of faces there and a couple of fingers up there too. So the first one is for right rate. The right rate means how much to apply. How do I know how much to apply? The first thing I need to keep in mind, to know how much to apply, I need to have all the inputs and outputs of Nitrate. So what is the tree demand? How much is the tree asking me to put on? That's the how much, the right rate. Once I know how much, I also need to know when to apply it. So that goes into the right time. I need to apply when the tree needs it. So once I know how much I need to apply, it makes sense to apply when the tree needs it. In other words, I have to be careful and not apply it when the tree is not going to be able to uptake it. So for instance, in winter, we know that the tree is not working, so applications around winter are very risky. They will leach because the tree is not actively uptaking nitrogen. So that goes into the right time. So the first one is the how much, and the second one is the when to apply it. The third one, where to apply it. So once I know how much I have to apply, once I know when I have to apply, I have to know where I have to apply it. I have to apply where those active roots are. And we're going to talk a little bit on that, about that later on. But I have to make sure that whenever I do a fertigation event, I'm trying to allocate that fertilizer where the active roots are. And I'm going to give you some tips how to do it. So that's the third one. The fourth one, I call it 2-in-1 because it talks about the right source and monitoring. So there are different options of fertilizers. There are organic options. In organic options, you have a bunch of different fertilizers. In organic options, you have a bunch of different options like cover crops and compost or things like that. And what you need to know is your source so you can better understand what are the benefits of that source versus others or the particular challenge. Each source has opportunities and challenge. And also monitoring, we're going to touch bases on that one. Once you're following these R's, you need to have a way to know if you're doing things correct, like a check, like a speed check. And we have worked a lot on developing a new tool for almonds, which we call the early leaf nutrient sampling. So you can sample now in April, and that will help you to know if you are doing things correctly. So that's the concept for R's, and also for Nitrate, and also while keeping in mind these 4 R's, at the Almond Board in our California Almond Sustainability Program, we have invested a lot of time to simplify this and to put together the results of our research projects in what we call the Nitrate Budget Calculator. And this is a step-by-step calculator that will help you to define how much and when to apply it and generate the reports that you will need in this area. So it's a user-friendly calculator. I invite you to use it to check where you're doing, and it's going to help you to follow best management practices. With that said, what I would like to do next is to illustrate the logic that it's behind that calculator, okay? Because I do think that by understanding the logic, we can really take very smart and better decisions on how to manage nitrogen. You won't need to do the math that I will walk through, but understand the logic, it will be great. And then you have these tools that will do the math for you and make the things easier. So the first thing to keep in mind for nitrogen management is that nitrogen is an act of balance, okay? Nitrogen management is an act of balance. The nitrogen cycle is an act of balance. In one part of the cycle of the equation, you have the supply rate, and in the other side of the equation, you have the demand rate. And those are the two functions that you always need to think about. What are my nitrogen inputs? That will give you the supply part of the equation. And what are my nitrogen outputs? That will give you the demand part of the equation. When we think about the supply part, we're talking about this area here that I'm highlighting. And you can see that the supply, all that is, meaning all the nutrients that's getting into my system, into my orchard, has three components. The cover crops, manure, compost, organic matter, the irrigation, the nutrient in the water, and the commercial nutrient fertilizer. And one thing that I have observed through time is that we tend to focus so much in that one, while in fact, we also need to keep in mind those other ones. And these ones, specifically that one, are free source of nutrient. So we should actually take the opportunity to use that nutrient and account for it, so the amount of fertilizer that we put actually, it's the supplement to provide the right rate. So that's about the supply function. Then when you start looking at the other sides of the equation, at the demand function, you can see that the demand in almond trees is mainly a function of harvest nuts. And yes, you need for to make that tree grow and for vegetative growth. But and we have studied all that, and we now have a very good idea of how much the tree needs to have adequate and sufficient and highly productive amount of nutrient, and good amount of nutrient to be highly productive. So those are the two that's the act of balance, the supply versus the demand. And it's an open cycle. Nutrient is an open cycle because there is volatilization going on, as well as potential leaching going on, as well as fixation in the soil going on. And our job as managers and as good nutrient management planners is, in my view, to reduce these arrows here as much as possible, reduce the volatilization and the leaching as much as possible, and match, meaning that I match the supply with the demand as best as possible. So let's talk how to calculate the right rate, okay? I'm going to show you 4 bullets, 4 steps of how the logic that I use behind to calculate the right rate. So the first thing is that you need to know the tree nutrient demand based on predicted yield. In almonds, we have seen over and over that the amount of kernels that you're going to produce tells you so much about how much nutrient that tree is going to need, that really having an early estimation of how much the tree is going to produce, it's a really good indicator of how much the tree is going to need in terms of nutrients, nutrient. So, and I get it. It's hard to know today, for instance, how much the tree is going to produce this season. But an informed guess is better than a blind guess. If you are in an immature orchard that is still growing and it's mainly in the 3rd year, 4th year, I don't think you should be, it's impossible that it's probably going to get 5,000 pounds this season. So maybe we want to use a very informed guess, the historical yield, the average of 4 previous years, and so on. And then we can adjust that through the season. But again, an informed guess early in the season, like today, is way better than doing it blind. There's a question there.
Okay, you have a young orchard, 2nd, 3rd leaf orchard.
Mm-hmm.
How would you calculate how much nitrogen you need for the tree to grow? Because you're, let's put it this way, in order if you want 2 feet of growth, you're going to have so much nitrogen for the leaves.
Yes. So in a young orchard, you are much more focused in vegetative growth than in productive growth, correct? And we have the numbers for vegetative growth and the guidance for young orchard. Okay, and once you are in a more mature orchard, the numbers I'm going to show you account for both, for vegetative growth as well as productive growth. And when you use the calculators, also when you have very low yield in mature orchards, it's going to compensate for vegetative growth. So long story short, in our studies, the amount of vegetative, if you account all the vegetative growth and you weight it and you calculate how much nitrogen is there, it's not that much. It's very little compared to the amount that is in the kernels. You're talking in the neighborhood of maybe 30 pounds in vegetative growth that is in the tree versus 68 pounds per 1,000 pounds of kernel that is in the fruit. Okay? So when it's growing, there are guidance, and yes, you have to focus in the vegetative growth and whatever you're going to get for fruit production. But it's way less than fruit growth. And if it's not growing, it's not because of nitrogen, it's because of other factors. Okay? So second, you need to calculate all the nitrogen credits. So once you calculate the demand, the how much, you need to calculate all the nitrogen credits that will come from the water, from organic manure, for compost, etc., from compost. And third, you calculate the amount of fertilizer needed. So it's the third part of the logic when you calculate the amount of fertilizer. Once you calculate the amount of fertilizer, then you need to apply it. And when you're going to apply it, you need to include the efficiency factor. Okay? And we're going to talk about the efficiency factor and the numbers that we use. This is the same thing. This is the same bullets rearranged in a different way, where you can see in this part of the equation the demand function, which will be how much the tree needs, minus the supply function, which, as I pointed out, is the sum of how much nitrogen is in the soil, in the water, and through fertilization. So again, fertilization is just one component of the supply function that has to keep in mind the other components and also responds to what the tree is asking for. To define how much the tree is asking for, and here's a little bit of the pictures that help us to identify how much is needed to produce fruit, to produce kernels. We did sequential harvests of the trees for several years. We collected samples across the year, and we measure individual tree yield, and we work for a lot of time with a big crowd to come up with these simplified tables. Okay? There are more data, of course, that came out from that project, but I think this table really produced a very good set of information to how much the tree needs. And here's where we incorporate that per every 1,000 pounds of kernel produced, there are about 68 pounds of nitrogen that are removed from the orchard. Okay? And you have the other numbers there for potassium and phosphorus. So that's a great piece of information. We now know, thanks to the results, robust results, how much nitrogen it's removed by the crop and how much the nitrogen the tree needs. So let's use a conceptual example to understand how much nitrogen needs and all this information I have given you so far, so we can reiterate what I'm talking about. So let's keep in mind this 68 pounds per 1,000, 68 pounds of nitrogen per 1,000 pounds of kernels. Keep that in mind and this equation in mind. So let's now think that we are in an orchard that the production is going to be 2,500 pounds of kernel per acre. Okay? 2,500 pounds per acre, or no more than that. So I go ahead and multiply 2.5 times 68 and gives me 170 pounds of nitrogen per acre. Why did I do that? Because 2.5 times 68 it's using the ratio of 68 pounds of nitrogen per 1,000 pounds of kernel. Okay? So that gives me 170 pounds of nitrogen per acre to support that yield. Then let's now assume that we have other sources of nitrogen, other inputs like compost and cover crops, and in the water, and let's say that all of them add up to 22 pounds of nitrogen credit. Are you guys following up to there? You got it? Okay. So we have a demand of 170, and we have a natural supply of 22. So 170 minus 22 gives you 148 pounds of nitrogen that are needed. Okay? So the 148 pounds of nutrients that are needed is not necessarily exactly what I need to apply. Okay? So that's what the tree needs. We calculate how much the tree needs, but now I need to incorporate the efficiency. So that's the how much. How much does your orchard need in these conditions to produce the 2,500 pounds? 148. Okay? So now I'm going to deliver those. I'm going to make sure that those trees get the 148. So I incorporate the nitrogen efficiency. In our studies, and we have observed higher efficiencies of up to 80% or so when we're following the 4 R's. And we come up with a conclusion that if you are following the 4 R's, the efficiency is 70%. So meaning that if your trees need 248 pounds per acre, you divide that by 0.7 and gives you 211 pounds per acre. Okay? So that is the application that it's being recommended. Do you guys follow that? Any question? So when is the tree need? If I follow the 4 R's, I have an efficiency of at least 70%, and then I can deliver, and then that means I need to deliver the 211 pounds. So what I would like to do next is to illustrate a couple, actually 4 examples where this efficiency goes down. And I like to do that because these are not random examples. These are the most common situations that we have observed that occur in agriculture systems, in orchards, in tree production, and are key because when our efficiency goes down, what do you think happens with that extra nitrogen? It can go down, up, it get lost. So having a high efficiency, it's key and good for everybody because what you want to do with the nitrogen, you want to make sure that it goes into the tree. So the amount that you invest into that nitrogen, it's recovered by the tree uptake. And you don't want to leach that nitrogen and have environmental pollution. So these are 4 examples. So the first example I'm going to show is application errors. The second one is year-to-year yield variation. And the third one is in-field variability. And the fourth one is between-field variability. And one thing I would like to say that it's not there specifically, but it's also part of all this, is the water uniformity, irrigation uniformity. All of this, it starts with having a good irrigation system, or a good management of your irrigation. Remember that in a technified irrigation system, you can get to efficiencies to deliver that water to the tree up to 90%. Okay? If you are managing that system correctly, if the uniformity coefficients are very high, and so on. So keep in mind that if your irrigation system is not performing adequately, your nitrogen, your ability to deliver nitrogen, is not going to be adequate either. Okay? So keeping in mind that a good irrigation system it's in place, here are a couple of more errors. In this table, you can see, and I'm going to focus your attention in the first column of the table, and this is the pounds of nitrogen per acre. And in each row are different orchards. And I would like to focus your attention in the last 2 orchards. So in this orchard, in the second to last orchard, the application rate was 225 pounds of nitrogen per acre. And in the other orchard, 450 pounds. So we have 2 orchards. In one we applied 225, and in the other one we applied 450 pounds of nitrogen, 2 orchards. Now let's focus our attention in the third column where we have the yield. In the second to last orchard, we have 3,830 pounds per acre. And in the last orchard, we had 3,679 pounds per acre of kernel. So again, the orchard that I applied 225 pounds produced 3,830. The orchard that I applied 450 pounds produced 3,679. What do you think happened with the efficiency? In this orchard, the nitrogen use efficiency was very good, was higher than 80%. While in this orchard, the nitrogen use efficiency was very low, lower than 45%. Because I apply in excess of what I produce, way in excess. So, and where do you think that nitrogen probably went? Downstairs. Okay? So the point here to illustrate is that every orchard is a unique decision. So if the orchards are going to have different yield potential or different yields, actual yields, the amount of nutrient that they should receive should be different. And according to that. Here's an example where instead of having 2 orchards, we're going to have 1 orchard. And I use pistachios, but it really doesn't matter that it's pistachios because it's to illustrate the concept and the principle that is the same across all fruit tree production. So this is one single orchard that we track for many years, in 2002, 3, 4, 5, 6, and 7. And we calculate the efficiency of that nutrient use efficiency. And being close to the dashed blue line means that the orchard was very efficient that year. Being close to the red dashed line means that we were inefficient, that the orchard was inefficient that year. And you can see how 1, 2, 3, 4 out of 6 times the orchard was very close, had a very high nutrient use efficiency. But all what it takes is to have a couple of bad years, a couple of years where the yield wasn't kept in mind or the demand didn't balance with the supply, and we have a lot of inefficiency in the system and nutrient leaching as well. So what in the first example, I tried to illustrate the point that every orchard is a unique decision. Here I'm trying to illustrate the point that every year is a unique decision that you need to take. So in the next slide,
excuse me, so
yep.
On the pistachios, you're
Yep.
still using the 68 pounds per 1,000 pounds of nuts?
No, it's another ratio. But I mean in this case, it's another number that we calculate. We have numbers for pistachio, for walnuts, for almonds. So this is the number for pistachio, but it's the same principle. It's the same challenge. In this third example, I would like to illustrate something that we call spatial variability. Okay? In this case, we have an 80 acres plot where we recorded individual tree yield, and we observe that there are areas of this 80 acres plot that are high yielding zones, and other zones that are very low yielding zones, and other ones that are somewhere in the middle. So this is, let's say that now you have one pump, one fertigation to fertigate all these 80 acres plot. How do you do it? How do you fertigate that so everybody is happy? I mean, if you do it based in the demand of these trees here that have high production, then you need to apply this. You will make this section of the orchard happy, but all of these ones will be in excess. If you fertigate so that these trees here are adequate, then these ones are going to be deficient. If you fertigate the average, if you use the average of the orchard, then nobody is happy. So how do you manage this? And I had to recognize that this is a challenge. And in the past, we didn't even recognize this challenge. Now we recognize it, and I hope that in the future we have viable tools to address it. Perhaps in the far, far future, we have the ability to inject fertigation according to the tree needs. That sounds really futuristic, but maybe not so much in the future. We could have a viable way to subdivide this orchard in 5 acres plot and instead of a 180 acres plot, and apply nutrient according to the demands of the different plots. Maybe not so far in the future, we could do it in 20 acres plot. Maybe even in the present, we can divide the orchard in 2 and just 1 bulb and save a lot in fertilizers and so on. So the solutions are going to be very particular to what is going to be the source of variability and so on. But what I'm trying to say is that walk the orchards, check those identify those low yielding areas, see why they are what the reason is behind to have low yield. Many times, I bet you, it's not going to be because of nutrient. But try to solve that problem so you increase uniformity of your orchard. And if you cannot, try to see, if you cannot do it, try to see approaches how you can reduce that variability as in this example. Here's the last example I brought, and this is hypothetical, okay? So let's assume these are almond orchards with different, and these are the yields per pound per acre. And you can see this is a macro picture, so you can see different orchards, different plots, different units. Some of them are very high yielding, let's say 4,953 pounds, near 5,000 pounds. Another ones are low yielding, let's say immature orchards growing, 1,500 pounds, and so on. Other ones are in the more 3,000 range or 2,000 range, and so on. So you have some orchards that are in their best years, best yielding years ever, and let's focus on those ones there in the corner, and other orchards that are still growing and in low yielding years. If I apply 275 pounds to all of these orchards, what do you think it happens? That's what happens with the nutrient use efficiency. You will have some orchards that are going to be above 100% efficient, and other orchards that are going to be below 35% efficiency. Is that good? Of course not. More than 100% efficiency means that these trees were deficient. We didn't provide enough nutrient to support that yield. On the other hand, less than 70% efficiency, this number here, 35%, means that we apply nutrient in excess, and a lot of that went into leaching, most likely. So the point here to illustrate is that not just the decision of two orchards is a specific decision, but if I manage multiple orchards, I have to come up with multiple decisions on how much to apply based on how much they will yield. Here's a slide that illustrates that in our studies we got about 80% of nutrient use efficiency. So just to show you, this was in following best management practice with the 4 R's. So enough about right rate and efficiency. Let's talk now about right time. And this is the only slide I brought about right time. And it's a very rich slide with a lot of information that I would like to illustrate and discuss with you. So here are the bullets, here are the message, the takeaway message that you have for you in your handouts that you can read later on. But let's pay attention a little bit first to this graphic. So in this graphic, you can see in the y-axis the percentage of soil nutrient uptake in the whole tree. So how much nutrient is the tree taking from the soil? 20%, 40%, 60% across the whole season. Here's the dates, okay? And here's the phenology. So from 70% leaf out to senescence. One thing that is striking here is that before leaf out, how much is the uptake from the soil? How much is the uptake before leaf out? 0. I see some hands there. Yep, 0. So what does it tell us?
Don't put it on
until leaf out, until middle of March or so on, correct? So that's a first takeaway message. Don't put it out. What's going to happen with that? It may rain, it will leach. So the tree doesn't need it. The trees, all of this occurs with the storage of the tree. So the tree is not actively uptaking nitrogen. And then you have a big slope, the tree really taking nitrogen from where? What is happening here? What happens here? The tree takes the nitrogen from the soil. About 90% of the, up to harvest, about 90% of the nutrient, the whole nutrient demand comes from the soil, is uptaken from the soil. So that tells us that that's our window of opportunity to make sure that whatever we apply is uptaken by, the tree takes that up. So based on this graphic, we have come out with best management practices and identify the times of the year where you are more efficient applying nitrogen. The current recommendation is that between leaf out and whole split, you need to make sure that you apply most of your nitrogen, at least 80% of your total plant. There is very little uptake that occurs at the end of the curve, okay? And specifically after harvest, there is very little uptake that occurs. There's mainly remobilization from the tree. From those leaves that are green start to become yellow. They change color because the green color, that is the nitrogen, goes back to the buds, to the trunk, to the perennial structures to support next year flowering, next year's leaf out. So doesn't take it that much from the soil. And if you keep in mind that after harvest, maybe your irrigation system is not performing at the best, or maybe your trees, you didn't have the opportunity to irrigate your trees on time, and they don't have that much leaf, or they had no leaves, and those leaves are the ones that are remaining are yellow, the uptake capacity of that tree in those conditions is going to be very low. And your capacity to provide that nutrient is going to be also very low because the irrigation system is not going to be adequate. So be careful. Be careful with that fall, late harvest application. It's definitely the highest risking, the high risk times are after harvest. These applications here and the applications here are the ones that are actually going to likely contaminate and are not going to be effective for our tree production. While on the other hand, the applications here are the most effective to provide what the tree needs. This is a slide about the right place. And here we did a simulation of, in a 12 hours irrigation cycle, we injected the fertilizer in the first 3 hours. Okay? So if you inject if you have a 12 hours irrigation event and you inject the fertilizer during the first 3 hours of that event, this is what happens in the soil underneath the ground. Most of your nutrient gets accumulated around 30 inches deep. What do you think about that? Good or not good? Not good. Not good because it gets accumulated beyond the active root zone that almond trees have to uptake that nutrient. It doesn't mean, so here in our studies, we have observed that most of the active roots that are responsible for the majority of nutrient uptake are in the first 18 inches of soil. So your goal is to make sure that that nutrient gets accumulated in those first 18 inches and not below that. So how do you do that? Instead of applying the nutrient during the first 3 hours, apply it in the second half of your irrigation event. Common sense, or not? So if you move your fertigation timing to the second half of your irrigation event, you are, by definition, you are making sure that the fertilizer gets concentrated here instead of there. Simple. Other things to keep in mind. If you want to catch up with the humidity of your soil, and you want to do a 24 hours cycle event in the second week of June, okay? Or May, let's say May. Second week of May, you want to do a 24 hours event. And then you're going to irrigate, instead of 24 hours, you're going to irrigate 4 hours at the following week. When do you do your fertigation? In the first week or in the following week? In the following week. In the following week, because if you put it at the beginning, in the first part of the 24-hour cycle, then you're going to put a lot of water, and that's going to leach. Well, if you put it at the end of that cycle or at the following week, you're going to have all that humidity already in the soil, and then you're going to put the nutrient, it's going to be converted very fast, and it's going to be uptaken very fast. So your management decisions on when to apply affect the right place. I'm going to skip the right source, and I'm going to go to the right monitoring. I would like to really mention that you can be proactive. And now you have a way to sample in April, send the samples to the lab, get your nutrient analysis, and have an idea of your tree nutrient status and how they are going to look by summer. So that gives you an idea and allows you to be proactive. And just as a comment about it, this is the leaf nutrient sampling. And before we started this project, we ran a survey to many growers like you. And the first question we asked growers was like, do you collect leaf nutrient samples in summer? And 90% of the growers say yes. So everybody collect the leaf nutrients and leaf samples, or most of the people collect them in summer. When we ran the second question, and we asked the same people, do you use those results to manage or modify your fertilization plan? 90% of the people said no. So everybody collects in summer, but nobody adjusts accordingly. And so we discovered that the problem with that was that for nutrient, not necessarily for the other nutrients, but for nutrient, because you need to apply it before that, it was too late. So it was a reactive, it was too late. There was no time. By the time you get the results back from the lab, there was no time to adjust. So we decided to move that early in the season, and we collected a lot of data, and now you have a robust sampling protocol to send the samples and have an idea if you need to adjust or not in May or June. So I will conclude by saying what I've been trying to say during the whole presentation, that you need to base your fertilization rate on realistic, orchard-specific yield, accounting for all nutrient inputs and adjust in response to spring nutrient and yield estimates. Make a pre-season fertilizer plan based on expected yield, less the nitrogen irrigation and other inputs. Conduct a leaf analysis in mid-April. And in May, review your estimations. Walk again the orchard. See if what you predicted as yield, it's the same as today. And change accordingly. If you think you're going to get less yield, then there's time to adjust. At harvest, review yields and adjust and do the post-harvest fertilization accordingly to the tree health and the capacity of your irrigation system. It has to be in good conditions. If it's not even worth to apply it. Here is a guidance of the time application that we were covering. And every field, every year, a unique decision. And there is no better person to take these technical decisions than you guys. So that's the invitation. Take those technical decisions. And a good guidance to do that is the nutrient calculator. Remember, it's available for free, and it's part of our California Almond Sustainability Program. So that's what I brought. Okay. Let's now cover irrigation. And I really like how irrigation can interact with the different sport populations, because honestly, it does it all year round. Here, in a spring, for instance, you have shoot growth. And you know that in the spring, the machine is growing, the tree is growing. And what is developing is these 1-year-old shoots. So if you if your management in irrigation isn't adequate, meaning either applying too much, as Luke was saying, or applying too little, you will have negative consequences in the overall tree health and in shoot growth, which then, at the following year, this structure is going to be too small. And then the number of spurs that you are going to have is going to be lower. reduced canopy size. And we know that that's also connected to smaller canopy size, smaller yield at the end, yield potential. So that's in spring. That's how your irrigation management affects your canopy size in spring. As you move through the season, probably where we are entering now, into early summer, irrigation management also has huge impact in kernel size. Remember, think about the fruit as in the first stages as a balloon. You have in March and April this balloon, which is mainly the hull getting air inside and reaching full size. And then by the end of April, beginning of May, it's the physiological things switch a little bit from putting air into this balloon to putting kernel weight into this balloon. So now it's a process and that's where we are right now in the season. We have already probably reached full size in terms of fruit size, but now it's the expensive process that starts to take place. Is when the carbohydrates and all that energy start to enter into the fruit and start to develop the embryo, the kernel that we eat. And we have seen in our study that water stress at this time of the year or a little bit in early summer has a detrimental impact in this third factor of the yield equation I was telling you, kernel weight, kernel size. This was a study that we performed where we say there was a significant water stress in May. And you can see in the picture clearly that the water stress plants were the kernels from there were 20% smaller than from the control. Well, that of course translates into a 20% less yield in the current season. So water, so far I've shown you, has a long-term effect, as you may have problems if you don't irrigate well in the spring, but also could have a very short-term effect impacting your current yield. That's why water management and all the management that we do is so dramatic, because it doesn't only affect what we see today, but it's also affecting what we see tomorrow. As we move from early summer to late summer, there is something very interesting going on as well. There is something going on in these spurs. Those spurs that were vegetative, those spurs that have leaves only, start to develop those flower buds. You can see there. So that's what we call flower induction, flower differentiation. That's what is happening at the late of the summer. And sometime August and September, depends on the variety, the tree already starts to decide how many flowers are going to be developed for the following season. How many flowers are going to open in February, March next year. So, and we have seen that during this process, the formation and the number of those flowers that it's formed is connected to your irrigation management as well. And remember, I said one thing. I said the game is a mix of numbers, but also quality. And here I translate to the later part of the season, where your management in early fall, during harvest or right after it, your irrigation management will affect the quality of those spurs, the quality of those flowers, the amount of energy that they are able to storage into these perennial structures and use it at the following year to bloom and have healthy, strong flowers. So I like this picture here because it's showing what I call a smooth leaf senescing process. You can see this is right after harvest, and the trees are going, or right about to be harvested, and the trees are going through what I call a smooth leaf senescing. There are yellow leaves there are green leaves, and most importantly, the trees won't look like they have no leaf at all after harvest. And that's what when I see, I get a little bit worried about, because so many times I understand there's a lot of things going on during harvest, and the ability to put water back on and the ability to promote this smooth leaf senescing is restricted. But believe me, promoting good smooth leaf senescing will help from those green leaves to become yellow. And they become yellow for a reason, because that green color is the energy, is the chlorophyll, it's the nutrient that gets translocated from the leaves into the spurs to have healthy flowers at the following season, strong flowers. So again, irrigation management is key all year round. And again, check the CAS irrigation calculator for more information in this area.